current, electricity.
This is a continuation or like a different?
This is the continuation of the section. This is a new chapter, right? Because
Oh,
first we talk about only magnetism, then we talk about only charges. Now we are going to discuss about moving charges, right?
okay.
Yes. And this is the first most important, or you can say this is the base of your whole electricity and magnetism, because you observe that only few questions or same type of questions was asked in the paper related to magnetism and static charge. Just the distribution of charge, how charges are going to be distributed. Same goes for magnetism, right?
Yes.
Was not no other variety in the questions or on the topics. So this is the most important chapter because it contains many new concepts, many formulas, many equations, and this is the base of whole electricity. And we also connect magnet with electricity in electromagnetism, right?
Yes.
Okay. So very first concept is that we already know in previous chapter, we only talk about rest charges, and rest charges mean when you try to move charge in conductors, because now we only talk about conductors because now, we have to deal with moving charges. In previous chapter, we
Yes.
talk about insulators because we are only talking about rest charges. So first of all, just write the basic definition related to current.
Okay.
So if you want to define current, so how we are going to define the uh, term of electric current, or just simple current in the section of current electricity? Any guess, any idea that how you are going to define? Because you know that it is related to the motion of charges.
Yes.
So any
So
guess?
like it's the movement of the charges maybe from
Mhm.
one area.
From one point to another.
Yes.
Okay. Okay, so basically there are many terms because in our daily life we also use the term voltage, electric current, and sometimes we mix up the concept of electric current and voltage because in daily life we are not going to talk about some specific terms. So that's why sometimes we just used to combine these terms and have the same concept of current and electricity and voltage. So
Yes.
for electric current, so in previous chapter, we discussed about the charges. So when we are going to write the electric current, so simply it is the amount of charge. This is just like the speed or velocity, right?
Yes.
Amount of charge, because we know we are talking about the charges of motion of charges, amount of charge passing through a point in a unit time, right? Simple definition.
Okay.
Or just passing through a conductor. Let's suppose if we consider a specific length of a conductor, and then we just count the number of charges in a specific unit of time, right?
Yes.
In a unit time. So this definition is almost same like the definition of speed and velocity. Only the difference is in velocity we are talking about the distance, and in this section we are talking about the
In
charges.
charge. Yes.
And you already know about that. What is the symbol for charge?
C.
That was the symbol for charge. And what is the SI unit for charge?
Uh, like
Coulombs.
the full word.
SI unit of charge is Q, coulombs, and the
Oh.
symbol,
Oh.
sorry, the SI unit for the charge is C, coulomb,
Yes.
and
C.
for charge, the symbol of charge is Q, right? I think that was on the last sheet. Okay, so we only talk about the symbol for,
Everyone.
okay, no issue. So for charges, we use symbol Q, right?
Yes.
Okay. Okay, so now if we want to write the formula, so it is the amount of charge. So basically for the SI unit of electric current, the SI unit of electric current is I. Q is the SI unit of charge over T. So this is a basic formula.
So
This
what
is,
is I?
I am writing it. This is for charge
Okay.
and I is for electric current, because C is already for Coulomb, C is already for Celsius. So that's why if you got confused that why we are using C for electric current, that's why we use I for electric current.
Okay.
Okay, so this is a basic formula related to electric current, very basic formula, and Q is for charge, that is Coulomb C, and I is for current. And now what is the SI unit for electric current? If we talk
Q.
about the SI unit for electric current, so normally in daily life, you observe that unit or that symbol that is known as amperes, right?
Yes, yes.
So basically we use symbol or the SI unit of ampere in our daily life to measure electric current. And normally when we measure the readings in voltage or volts, so that is for voltage, right? So that
Yes,
is
yes.
the difference. So this is a very basic concept related to current, the definition, formula, and SI unit. Now let's talk about some other terminologies related to current, because now we are talking about the moving charges, right? So when charges are going to move, and we already discussed that the electric field always flow from which point to which one?
Positive to negative.
Positive to negative. Good. So now we need to also know about that in which direction or from which direction. We say that that now in which direction current is going to move. Either it is going to move from positive to negative or negative to positive, right? So
Yes,
basically,
yes.
when we are going to the directions of current, so there are two types of terminologies we use for electric current. One is known as conventional current, and the second one is known as non-conventional, right?
Yes.
In early stages, when scientists are discovering different terms and different laws and different principles, so scientists think that current always flow from negative to positive, the same concept of a free electron, right? Because in early
Yes, yes.
stages they are discovering everything, they are discovering or they are talking about the structure of atom, all other discoveries, all other laws. So in initial stages, scientists think that current will always flow from negative to positive, right?
Positive.
Because
Yes.
we know that electrons are free to move, so that's why they consider that electric current will always flow from negative to positive, right? So that
Yes,
is
yes.
known as non-conventional current. Basically this conventional and non-conventional tells you about the direction of current, right?
Yes, yes.
In our daily life or in new laws of physics, we are going to use only conventional current, right?
Yes, yes.
So this is our daily life use, conventional current, and in this case electric current is going to move from, I will write in detail. So conventional
It's
current,
for conventional.
yes, current will flow from positive to negative. Current will flow positive to negative terminal, right? Because
Yes,
now
yes.
we are going to talk about the conductor and terminal of battery or terminal of the main supply. So that's why current is going to be flow from positive to negative. And let's suppose in your exams sometimes they ask about that what will be the direction and what is the direction of non-conventional current. And sometimes in diagram they also used to ask that draw the correct direction of electric current, which is non-conventional, or what will be the direction in the circuit that is non-conventional current. So you need to draw from negative to positive, right?
Positive. Again.
If they talk about non-conventional, so you need to draw from negative to positive. In this case, electric current will flow
Oh,
from negative to positive, and otherwise conventional current is our daily life, or we can say that this is our main concept related to electric current. When we talk about electric current, so always remember that we need to consider electric current from positive to negative charge always, unless they ask you about non-conventional current, right? If they mention in the question, or if they specifically ask in your question that tell us about non-conventional, or tell us about the direction of non-conventional, then you will write that from negative to positive. Otherwise, always you need to write from positive to negative, right?
Yes.
And one more term which is also we can say that we can also replace non-conventional with an other term that will be more easy or very simple for us to memorize it. A non-conventional current will also known as electron flow, right?
Yes.
Because we know that in non-conventional, electric current is going to be flow from negative to positive. That is the old idea about from the scientist. So that's why we consider that electron flow as non-conventional. So that is very clear, because 50-50 that was time that in some papers they ask about electron flow, and only in few papers they ask about non-conventional, right?
Yes.
Okay, any confusion?
No, no.
Okay. Okay, so furthermore, if we talk about the type of current in our daily life, right? Type of current means basically there are two different categories, we can say that, or two different types of current in our daily life. If you observe different devices in your daily life, just like the charger of your laptop, charger of your mobile phone, LED or bulb, etc. So in
Yes.
all these devices, if you observe the backside of those products, or the we can say that any the information related to that product, so you observe that there are some symbol written with that, like AC, DC, and also there is some number written below or just behind AC or DC, like 40 AC or 50 DC, like this. So basically that
Okay.
AC and DC. So AC means alternating current, right? And DC means direct current. First, I will tell you what is the difference between AC and DC. Then we will write the all configurations related to AC and DC. Okay, let's suppose if you are using a cell or a battery. Cell means a dry cell we use in our remote
Yeah.
or different devices or different toys, or if you are using battery. So in battery or in batteries, you know that there is a fixed positive terminal, the red one, and there is also a fixed negative terminal, the black one, right?
Yes.
So whenever we are using cell batteries, so all these type of sources are known as that these batteries or cells are going to be supply direct current, DC, right? Because we know that
Yes.
one terminal is positive, second one is negative. So very simple, that current is, or we can say that, because we know now that we are using a term current. So always remember that we are talking about moving charges. So DC means that charges are only going to be transferred from battery to the source,
Yes.
right? Let's suppose if we are
Yes.
using remote control, so charges are only going to be transferred from that cell or that battery to remote control, right? Once all charge got confused, or the health of the cell is going to be zero, right?
Okay. Yes.
So that is the concept of DC. And where we will find AC, when you are using, let's suppose if you are going to charge your mobile phone, right? So you plug in your charger
Yes.
in main home supply, right? So
Yes.
your complete wiring in of your housing. So basically that source is known as AC current, right? Because we know that there are big transformers in our society or in our town that supply electricity
Yes.
to all the houses in the society or in the town, right?
Yes. Yes.
You also know that we are not going to charge that transformer again and again. Once it got fixed, so electricity is going to be supplied continuously, right? Because that one
Yes. Yes.
alternating current. Alternating current means there is no fixed positive and negative terminal, right? Current will always change its direction backward, forward, right? So in this way, we are
Okay.
going to charge any specific thing, right?
Yes. Yes.
So that flow of charges will always remain in motion. So that's why that source is known as AC. And when we are going to design appliances, so we need to know about that either these devices going to be operate on DC or AC. You also know that in our daily life we use these AC and DC inverter terms for ACs and different type of devices, right?
Yeah.
So
Yes,
that
yes.
is the concept, right?
Okay.
So now if we talk about direct current, because mostly in our lab or in our daily life we are going to deal with cell batteries, so that is
So even motors and like those things are also AC, right?
yes.
Like, uh,
So all the sources which are coming from the main supply or from the house wiring or from the transformer or the main power supply, so all those sources are AC. And whenever you are using a fixed source, like battery is a fixed source, you are not able to increase the amount of charge in the battery, right? Unless you buy
yeah.
a new battery. So basically for direct current, we just simply write it as the flow of current. So the flow of current in one direction. And you already know about direction, that if we are talking about conventional, so it will be from positive to negative. And let's suppose if they are asking about non-conventional, so it will be from negative to positive, right? So I'm not writing
Yes.
direction. Okay.
Okay.
And if we compare it with the alternating current, that is AC, the second one is alternating current.
Yeah.
So in alternating current, DC is for direct current. We also have symbol of DC in Marvel comics, right? DC comics. So that is not direct
Yes.
current. That is something different.
Okay.
Yes. But now when we study physics and when we ever saw these type of terms, so we always remember that this is related to DC or something, direct current or
Yeah.
something. So basically in alternating current, current basically flow. It will work like just like vibration. Let's suppose if there is a swing or a pendulum, once you start the motion of the pendulum, so pendulum will oscillate to and fro. So that is same for the AC, that current will always fluctuate or change its direction back and forth in a very short interval of time, right?
Yes. Yes. Sorry. A call was.
Yes, so current will change its direction in alternative. Okay, now if we want to draw a graph, right? Because sometime we
Yeah.
need to know about the graphical representation, because in physics, we in motion chapter we discuss about the graphs. So most of the time they ask you the concept in the form of graph. So you also need to know about the concept of the graph, that how graphs are going to be drawn for both direct and alternating current. So let's suppose if we first draw, or if we first consider a graph for DC. So this is our
Yeah.
y-axis and this is for the AC. X-axis. This is x-axis for AC. Now let's mark the parameters on x and y-axis,
Okay.
because we are going to measure them with respect to time. And you know that time is independent quantity. So we always place independent quantity on x-axis, right?
Yes, yes.
So time will always be on x-axis, and on y-axis we are going to talk about electric current, right? We are not writing the charges. So this is the direction of electric current. This will be also a
This is like a diagram for what?
this is the graphical representation for DC and AC, right? Basically it represents you. This is x-axis
Yes.
and this is y-axis. So basically we are talking about the graphical representation, that how you draw a diagram for the DC current. Let's suppose if they ask you to explain DC in graphical representation, right? Just to draw a simple graph that will give us a concept that how DC current will look like, right?
Okay.
Because in graphs we also deal with the directions, we also deal with the magnitude, right? So let's suppose
Yes, yes.
if we first consider with a DC current, so we write the definition for DC current, the flow of current in one direction. So we need to first fix one direction, right? Okay,
Yes,
now
yes.
I've drawn over here two values of electric current. So basically this is for positive and this is for negative, right? Because we have two terminals, so current will also move. Let's suppose if you put a cell in your remote control in reverse direction, right? The negative
Yes.
of the cell is with the positive of remote control and the positive of the remote control with the negative of cell. So you observe that remote control is not going to work, right? Because you change the charges, or you change the
Charges.
direction of that cell in your remote control. So basically that is the negative direction, because we reverse the direction. Normally it will flow from positive to negative, but when we change the terminal of the cell, so the direction of electric current will also reverse and your circuit will remain incomplete, right? So basically that
Yes.
is the negative direction that you are going to change. Or let's suppose if current is moving in forward direction, in DC, so if we reverse the direction, like current will move in backward direction. So basically that is the negative, the positive negative concept, right?
Yes.
So normally in DC we talk about the positive, because once we design some products, so that will always operate when current will flow from positive to negative side. So let's suppose if we are having a specific value of electric current over here. I'm not writing the values because this is a just journal outline of DC, right? We are not going to
This
solve.
one, this. Okay.
Yes, because this is a journal format. We will solve questions in numbers related to electric current also. So you know that with respect to time, or with the reference of time period, electric current will always move in single direction and the value of electric current will remain same, right? Because on
Yes,
battery
yes.
it was written that either battery is of 1.2 ampere or 1.5 ampere, just like the cell that was of 1.5 ampere. So current will always be same with respect to time. So this is the graphical representation for DC current, right? Very simple, because the value of electric current, let's suppose this is 3 ampere. So it will remain 3 ampere
Yes.
till the time unless this cell is going to be drained completely, right?
Yes.
And now for alternating current for AC, we know that in alternating current, the direction of current will reverse, or we can say
Reverse.
that the direction of current will change alternatively, right? So it will move in upward, downward motion, right? So the graph for
Yes.
AC will be like a water wave, like this. So this is the representation for AC, right?
Yes. Yes.
So that is a very simple concept, because current is going to be moving forward and direction, in and backward direction. And why we are using a waveform? Because we know that the value of electric current is in continuation. So there is no break in value of electric current. So we need to continue with the reference of time. First it will move in the positive direction, then it reverse the direction, it will move in downward. And since time is continuously moving on, because time is independent quantity, so that's why these values are going to be in form of waves, right? Let's suppose if time is at a stable point, let's suppose we are talking about 5 seconds. So only 5 seconds there will be a specific point, right?
Yes.
Because time is independent quantity. So that is why the variation of electric current.
How is it independent? Like,
How
how is the time independent? Like, that.
time is independent means, let's suppose time independent means we are not going to control time by ourselves, right? Let's
But you
suppose
did like five seconds is controlled, right?
basically we are just measuring that specific quantity in a specific interval of time, right? time is basically independent in a sense. Let's suppose if we consider the daytime and nighttime, so we are not able to control daytime. Let's suppose our
Oh,
days 24 hours, so we are not able to extend it to 30 hours, right? It will remain
yes,
its original slot in original timing. So in that sense, time is independent, so we are not going to control time. We just
oh,
manage our things with related to time. So in that way,
oh,
time is independent. We are using a stopwatch. That is your concern, that we use stopwatch like 5 seconds. So that is the control time. But we are not going to control that time. Let's suppose if we start from 3 minutes, so after 5 seconds, time will be 3 minutes and 5 seconds. We started from three. If we control time, so time will still remain at three, right? But after
yes,
5 second, time will be 3 or 5 seconds. So basically that is the concept of dependent and independent, right?
oh.
And
And independent is the one you can change.
dependent means now, just like the definition of electric current, that we are going to count number of charges in a unit time. Basically current is a drive quantity. Current individually is nothing. Basically current is a amount of charges passing through a point in a unit time, right? Just like a
Yes,
traffic signal, let's suppose if there is a specific signal and we are just counting the number of vehicles passing through that signal in 1 minute, right?
yes,
So basically that is dependent quantity. That quantity is dependent upon time, right?
oh,
Let's suppose if in 5 seconds, five vehicles cross the signal, right?
yes,
You may increase the vehicle, you may decrease the vehicle, it depends upon you. So basically that is dependent quantity on time, right?
oh,
Any confusion?
no, no, no.
So this is graphical representation for
Oh.
AC and DC.
So when the question will they come like you are just explain or
Basically,
like this.
yes, when we continue with some other countries, because now we only talk about current. When we talk about voltage, resistance, and there are some applications related to current voltage, so you have to draw the graph. So you need to know about the graphical representation, because in some time in some question they just give you the diagram of DC or AC, and you need to extract the value from that graph. So that's why it is important to read the graph. So reading the of graph or
Hello.
of values from the graph is very much important, right? Basically, sometime a question asks you about to extract the readings from the graph, right?
Yes.
So that's why you have to know about that, how we going to read the values from the graph. So that is very much important, right?
Yes.
Okay, I not mention the values or the sources. So if we talk about the sources, so for DC, you know the sources. So these are the sources for DC, right? Cells, batteries.
Yes.
And for alternating main electricity or the those heavy generators, right?
Yes.
So I'm just writing mains, that is for electricity, and the other one like the generators. Okay.
Oh,
So these are the applications or the sources of AC and DC, right?
yes.
Okay, further now, we will talk later about the devices, because in daily life you know that we use ammeter to calculate the value of electric current, because
Yes.
uh, ampere is the SI unit of electric current, so that is also the same like name ammeter, to count or to measure the ampere, right?
Yes.
Okay, now the next term is related to, okay, now we are going to talk about voltage and potential different, right? In daily life we use the term voltage, but in scientific term there are two different, or we can say that in scientific form there are two different terms. One is known as EMF, electromotive force, right? And the second one is known as potential difference. That is or in generally we use voltage for both EMF and potential difference, but there is a
Yes.
difference in EMF and potential difference. These two terms are very much different scientifically, but in our daily life we only use a single term, that is known as voltage. Both are voltage,
Voltage.
but there is a difference, right? Just like mass and weight, we use a mass and weight in our daily life as a single term. We count mass as a
Yes.
weight, or we just know weight as a mass, anything we are using in our daily life, but there is still a difference between mass and weight. Both are different quantities. So after electric current, we're going to talk about the voltage, and in voltage there are two different terms. So the first one is known as electromotive force, EMF in short. Electromotive force, or in short we may use concept of EMF, right?
Yes.
Okay, basically let's suppose if we are using a battery with a circuit, you know the terminals, right? And now you need to
Yes.
know about the symbols of different components, right? Because we are not going to use a 3D diagram, we just draw a symbol for a diagram, right? So whenever we
Yes.
are going to draw a diagram of battery or any source, so that will be simply like this. One terminal is greater than the other, and the greater terminal is for the positive, because we know conventional current will always flow from positive to negative, because positive is high potential. I will also tell you the concept of potential, what is potential in the concept of potential difference, right? So basically this terminal which is greater in length is known as the positive terminal, right? Always it will be positive. So you need to find out the greater line, or the line of a greater length. So the length, or we can say the line which is greater in length, is known as a positive terminal, and a shorter line is known as negative terminal, right? It will
Okay.
always remain same.
Okay.
And sometimes there are more than two lines, so you need to count from the extreme left and from the extreme right. Okay, one terminal is always greater than the other. When we
Okay.
solve the question, so you will observe that, no issue. And let's suppose if we connect a single lamp, okay, and the symbol of lamp will be like a circle and a cross in a center. This is a symbol of a lamp. I will also write the name of these components which are connected in a circuit. So
Okay.
basically this is a lamp, and this is a source or a battery or a cell, right?
Okay.
Okay, now when we connect a battery with a source, right? Sorry, when we connect a battery with any device or any component, right?
Yeah.
So basically the voltage which is going to be transferred from battery. Okay, now we are using a battery. So if we consider the type of energy, so what type of energy in battery is? Let's suppose if we are talking about a dry cell. I hope you studied about dry cell in your lower secondary classes in chemistry.
No. No.
Okay, if you don't remember, so basically that is combined from a chemical or different chemicals, right? Because we use different type of powder or some liquid material in a dry cell. Because if you
Yeah.
observe a broken dry cell, so there will be a black powder in it, right? Initially it will be like a yellowish liquid like honey, right? And after some
Okay.
time all charges are going to be drained, so it will be a powder form. In simple word, batteries are basically work on chemical energies, right? And that chemical
Yes.
energy converts into electrical energy, right?
Yes.
Because you know that in the batteries of car and bike also we sometimes fill liquid type material in it. So basically that is liquid or that is chemical energy. So we
And
use
okay.
chemical. So when we are going to connect battery with the component, so what is going to be happen over there, that chemical energy is going to be transferred from sorry, transfer to electrical energy, right? So basically there is a
Yes.
transformation of energy. So when we are talking about EMF, so basically EMF means electromotive force. So we used to measure that how much energy is required for a single charge to drive that charge throughout the circuit, right?
So like how much energy to require the lamp to work?
Yes, or in simple word, we can say that the definition for the electromotive force will be like this. The work done means to move a charge from one point to another, right?
Yeah, yes.
So the work done by a source will be anything. It will be battery, it will be a cell, right?
Yes, yes.
In moving a unit charge around a complete circuit.
This is the definition of the electromotive force.
Yes, yes, electromotive force.
Okay.
Because there is a force. So basically going to drive a quantity or going to calculate a quantity for a unit charge, right? Then we will multiply
Yes,
with the number of charges and we will get the complete voltage, right?
yes.
So let's suppose if we are using a battery of 9 volt. So basically 9 volt is going to be transferred throughout the circuit, right?
Yes,
And it depends upon the components which are connected in the circuit that how much voltage are going to be consumed, right? Otherwise 9
yes.
volt is going to be driven through whole circuit. And when we are going to write the formula for it, so the formula for EMF will be E is equals to, or we just simply write EMF equals to the symbol for work done will be W, and again we are driving a charge throughout the circuit. So that
The
is,
Q is the current.
no, again charge. Q is for
Oh,
charge, I for current, right?
okay.
And this is a work done, and E is simply EMF, right?
Yes.
So basically this is the equation for EMF, because these concepts are very confusing and all concepts are like same. So that's why we are going slowly in these topic, because this is the base. Once you got the clear concept of EMF, current and voltage, so all things will be easy, because this is the base. Once you got confused in EMF, voltage and electric current, so always you got mess in your questions while solving questions of electricity and magnetism, right?